In this video, we're going to talk about methods of collecting data. Again, in this course, we're not actually going to be doing this. The data is always just going to be handed to us and we're going to analyze it. But in case you ever do need to collect data at some point in the future, it's probably good that you've at least seen this. This won't be on the test or anything, but it's good for you to at least have an idea of the different methods that are involved. In this video, we're just going to talk about the general categories of data collection methods. In the next video, we'll talk about more specific things you can do. So the first thing you can do is just an observational study. In an observational study, all you do is observe. You do not try to affect the outcome. I mean, you do everything you can to make sure you don't affect the outcome. You just have some situation, you watch it run and see what happens. So one example would be like Darwin when he went to Galapagos Islands. All he did was he watched birds for a few months. He didn't say feed one bird and not feed another bird and look and see what happens. He didn't try moving a bird to a different part of the island, see how that changed things. He did nothing. He just went to the island, watched what the birds did. Another example would be if you are interested in baby development. So if you read any baby book, it'll tell you, oh, babies should teethe at about 6 months. They should walk a little before a year. Tells you when they talk, yada, yada, yada. No one did experiments or anything to figure this out. You just watch a bunch of babies and say, hey, most of them tend to get teeth somewhere around 6 months. So that's observational studies. Next up, we got experiments. In an experiment, you deliberately try to produce results. And in order to do that, you're going to have two groups. You're going to have a control group and a treatment group, which this language is more for like if you're doing medical stuff. There's slightly different wording if you're doing scientific experiments, but this basic idea is always the same. So this control group, you have to have some example that really just mimics the observational study. You're just watching them. You're giving them something that looks like treatment, so some sort of placebo, to make them think they're part of the experiment, but they're really just a baseline to compare to. And then you have the group that you're actually treating, and you try to see, well, how does this group's results differ from that group's results? So, famous example would be like aspirin. For men, anyway, at least. So there was a big experiment where they thought, okay, aspirin can reduce the risk of heart disease. And so they got a whole bunch of men, put them all on aspirin regimen. Half of those men they actually put just giving them a sugar pill instead, and the results were overwhelmingly different. The men who actually took aspirin had a much lower risk of heart disease than the men who were just taking a sugar pill. So in this case, the experiment actually got canceled halfway through because like there's no reason to continue. We might as well tell all the guys like, yeah, start taking aspirin. Another example, well, this is relatively recent. The scientific method actually got started with Isaac Newton. Before then, science was more of an observational thing. If you ask people, oh, why do things fall when you drop them? The reason that people usually gave, well, things want to be closer to the earth. So if there's nothing to stop them, then they will fall. Newton realized, hey, you can get a whole lot better, more accurate predictions if you actually set up experiments and try different explanations instead of just going with what sounds good to you. So he came up with the scientific method, which is hypothesis, yada yada yada. Hopefully you've heard it at some point. Alright. Next up is a simulation. It's basically like a fake experiment. You're not actually doing an experiment with the real thing. You're building some sort of model. It could be on a computer or it could be a physical model. But there's some reason you don't want to do the actual experiment. And so you make kind of a fake experiment. So a simple example would be using crash test dummies. You don't want to know, I mean, you'd like to know what happens when a human gets in a crash, but you don't want to actually put humans in wrecks and see what happens for a real experiment. So you make some sort of dummy that breaks at about the same strength you think a human is going to break at, and you put them through crash tests. So you do that instead of actually using real humans to do an actual experiment. And last but not least, we have a survey. Survey is more particular to statistics itself rather than to science and things like that. Basically, you just ask people questions. That's all there is to it. The main thing you need to do with the survey is make sure you do get a representative population and that you word your questions without bias. But that's really all there is to it. You want to know what TV shows Americans watch? You ask 100 Americans, hey, what TV shows are you watching? So, alright, there's some ways to go about collecting data. And again, this won't be on the test, but it's just good for you to have seen it at some point.